These are the voyages of Mission 5, Lesson 36, where the objective of Mission 5, Lesson 36, its mission is to represent the multiplication of n times a, b as n times a over b using the associated property and visual models. Wait a second. Isn't this the same student objective as the previous lesson? Yeah, it is. This is the same student objective as the last lesson. And because it's a mouthful, it's a tongueful. Blah, 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 blah. N times A over B as N times A over B using the associative property and visual models. Whew. Okay. Again, we're going to simplify what this means for today. Previous lesson, we multiplied a whole number times a fraction. Today, we're going to be multiplying a whole number times a fraction. What's the only difference, though, today? Today, we're not going to leave that number, once we multiply, as an improper fraction. We're going to convert it into a mixed number. So we're just adding one more step. So let's take a look at an example. Here's that aforementioned example I was just referring to. 8 times 5 sevenths. Okay, so again, we have a whole number 8 times a fraction 5 sevenths. So from our previous lesson, we know to multiply these, we just multiply our whole number times the numerator. So 8 times 5 is 40. And then what happens to the denominator? It stays the same. Sevenths, 40 sevenths. Now, in the previous lesson, we would have been done. We would have said that's good enough. But now today's lesson, we're going to take it a step further. And we're going to take this a step further by converting this now into a mixed number. Because, as you know, 40 sevenths is an improper fraction because the numerator 40 is greater than the denominator 7th. Right? So that tells us it's worth more than one whole. Our job is to now figure out, okay, how many wholes are in this, and then what fraction am I left over with. Here's the thing. When you are taking an improper fraction like this, what are we actually doing? What we're actually doing is dividing. 40 over 7, and we're trying to figure out, okay, how many wholes are in that, and what fraction is left over. That is the same as saying, hey, what's 40 divided by 7? How many times does 7 go into 40 without going over? It's the same skills that we've already had. Wait, hold on a second. I'm going to listen. Yeah, that was your brain exploding, your mind being blown. Seriously, it's the same thing. This is division. 40 over 7. 40 divided by 7. So I'm just going to ask myself, well, how many times does 7 go into 40 without going over? So how many times does 7 go into 40 without going over? Or I could also think of it as, 7 times what? I could also think of it 7 times what number gets me as close to 40 without going over? Well, here's the deal. I know I can't multiply any number times 7 to get 40, right? I can't do it. But what's the closest I can get if I'm counting by 7s or multiplying times 7 to get as close as I can to 40 without going over? Well, let me think here. If I know 7 times 1 is 7. I know 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. I know 7 times 5 is 35. Okay, we're getting close. I know 7 times 5 here is 35. So I know I'm getting close. What about 7 times 6? 7 times 6 is 7, 14, 21. Double that, 42. Uh-oh. See what just happened here? I went over 40. So I know 6 is too much. There are I can't go to 6 wholes here. So what's the closest I can get when I divide? It's 5. 5 times is the closest I can get without going over. Sometimes 5 is 35. So what I'm saying here is, how many wholes do I have? I have 5 wholes, right? Because I can pull out 7 from 40 5 times without going over. Now, what am I left over with? Again, this is just division. So what I'm really asking is, what's my remainder? So if I know 7 times 5 is 35, that's the closest I can go without going over. Well, what am I left over with? Well, it's just 40 minus 35 is 5, right? So 40 minus 35 is 5, so I'm left over with 5/7, just like that. All right. So what did we just do there? So if I convert that, that's 5 and 5/7. I just converted an improper fraction into a mixed number. And I did that by using division. Now, is this the same as going... Let me change that. Let me change that color for it a little bit here. It's going to look a little Christmassy. So 5/47, that's the same as me going... I'm going to erase this just to give myself some space. Get out of here. Go away. Go home. Nobody wants you here. Actually, I'm feeling kind of bad. I felt like I just was kind of being mean to those numbers there, but trust me, they don't have feelings. Okay, so it's the same as when we had 47s. If you were pulling out all your 7/7, saying, okay, I've had 7/7, 7/7, 7/7, 7/7. I'm just pulling out the whole numbers, right? 7/7. It's the same as doing this, because that's 7, 14, 21, 28, 35, which is 1, 2, 3, 4, 5 holes, and having then, that gets me to 35 and having 5/7 left over. It's the same thing as using the number bond like that. So you could always do that as well if you want. But again, it's just division. It's just division, and we have those skills. Okay? 40 divided by 7, or whatever your improper fraction is. Okay? So that's what we're doing in today's lesson. You're going to multiply a whole number times a fraction, and then convert that fraction, which will be improper, into a mixed number.